In this problem, we're given a person who's 25 years old and currently earning a salary of $35,000 annually. They expect to retire in 40 years or at age 65. Inflation is going to be 3% annually. And you're asked to determine what your annual need for retirement is in today's dollars, assuming you're trying to replace 80% of your income. I'm going to demonstrate this in Excel, but you could use a regular calculator and pen and paper. So, um, my annual need in today's dollars, I'm trying to replace 80% of my income, so I take that 0.8 and multiply by my current salary of 35,000. So basically, before taxes, I want to try to uh, generate a retirement income in today's dollars of 28,000. However, if I withdraw 28,000 or save up enough money so that I can withdraw 28,000 every year, I will have to pay taxes on it. And I think my tax rate during retirement will be 20%. So what I really need to generate is 28,000. Actually, I will type those in. Divided by 1 minus that tax rate of 20%. So I actually need $35,000 so that once I pay my 20% tax rate on it, I'll have 28,000. And just to show you, the 35,000 times 1 minus the 20% will give me the 28,000. So basically, what I need to try to do is save up enough money so that in today's dollars I can withdraw 35,000 every year. It's actually going to turn out to be much more than $35,000 a year once I pull it forward at the rate of inflation for 40 years. And that's what question C asks you to do. You know you want to try to withdraw the equivalent of $35,000 in today's dollars. But you also know there's going to be inflation for 40 years. So what we want to do is figure out what this amount will be 40 years down the road after being inflated at a 3% rate every year. To solve that, I'm going to use the TVM calculator that I've demonstrated a few different times. So our present value in today's dollars is at $35,000. We're pulling it forward at 3%. There's no payment, and we're pulling it forward for 40 years. And we want to know the future value. So basically, in 40 years, to have the equivalent of $35,000 today, I'm going to have to save up enough to withdraw $114,171 every year. And that's not adjusting for inflation that follows after you hit retirement. So I'm just going to copy this number over, pop it back in Excel. And remember, whenever you work calculations on the time value of money calculator, it always returns a minus sign. If you watched my other videos, you'll be familiar with that. So for the very first year of retirement, I'm going to need to withdraw $114,171. Then, once I pay taxes on it of 20%, that remainder will be equivalent to $28,000 in today's dollars. Now the question asks, basically the day you retire, you're not going to be saving any more money after that. You're only going to start withdrawing money. So the day you retire, how much in total do you need in your account so that you can withdraw at first $114,171. The second year you'll withdraw this amount inflated by 3%. The third year you'll withdraw that amount inflated by 3% again, and on and on and on. So you're going to need a huge amount in retirement, in your retirement savings, so that you can withdraw this the first year, this plus 3% the second year, and on and on and on, so that by the time you hit age 85, because it says, I didn't type it up here, but it says you plan to live for 20 years during retirement. So by the time you hit age 85, you won't have any money left. And some things to remember, inflation will be 3% every single year. And you can earn 4% while your money is sitting there not being used. So let's say you've got $3 million. It's going to sit there for a year, earn 4%. So it'll be worth 3 million times 1.04. Then you're going to take out 114,171. So you'll have $3,120,000 less 114,171. Then this money is going to sit here for a year and earn interest. So it'll be worth 3,000,5,829 times 1.04, or 3,126,000. Then you're going to take out the previous year's amount times 1 plus inflation. So you're going to take out this much. So at the end of that year, you'll have 3,084,066. So basically, the question is asking, how much do I need to have here so that after 20 years of doing this, I won't have any money left? The answer's got to be less than 3 million. I just made that 3 million up. But I can see that following this current pattern, I actually end up with more money the second year than I started with the first year. So basically, I've got a very large amount here, and the interest that it's earning is more than offsetting the amount I'm withdrawing, even though the amount I'm withdrawing is increasing. So again, that's the question. How much do I have to have the day I retire in my account so that I can withdraw this amount that is increasing at the rate of 3% every year, but whatever money I'm not using is earning 4% every year? I will solve for that using the TVM solver, which I need to find. There it is. I am just going to reload it to get it back to blanks here. So in this particular scenario, I'm solving for present value. And the rate that I will be using, I'm going to talk about payment first. The payment will be initially $114,171. And there are 20 years that I plan to live during retirement. There's no future value for me to worry about. Present value is what I'm solving for. The rate is a little odd this time. The rate needs to be a rate that considers the fact that this payment is increasing at the rate of 3%, and the money that I'm not using is earning 4%. So if I take the rate that I'm earning of 4% and subtract the rate of inflation of 3%, that gives me 1%, and that's the rate I actually can input here. And the financial calculator will increase this by 3% in essence, and discount the money that I'm not using at a rate of 4% to solve for the present value. So I need $2,060,279 in my account the day I retire. Now I'm going to start saving money. Right now I'm only 25 and I have 40 years to save for retirement, and I need to have saved this 2,060,000 40 years down the road. And the question asks, how much do I have to save every single month so that 40 years from now I will have $2,060,000 in that account, assuming I can earn 8% on that money, 8% annually. So again, I'm going to just reload to reset everything. This time I'm solving for a future value, and I have no present value. My rate is going to be this 8% divided by 12. So 8 divided by 12 gives me 0.667. And I'm going to carry it out a few decimals because if I rounded it straight away to 0.7, let's say, it's going to give me a pretty hefty rounding error, and I would rather not have rounding errors if I can avoid them. My payment is what I'm actually solving for. The number of time periods will be the 40 years times 12 months, or 480. So I've entered a monthly rate and a monthly time period. Because I've adjusted the rate and the time period myself, I can leave this set at annual. And my future value is that 2,060,279 that I'm attempting to accomplish. So basically I'm going to make some payments every month for 480 months. They will earn a rate of 0.667% a month. What payment will accomplish this $2,060,000? So if I save $590 a month, I save $590 a month, that will grow to $2,060,000 after 40 years, and that will allow me to withdraw $114,171 the first year, 3% more the second year, 3% more than that the third year, and so on. And all that equates to having the equivalent after-tax income of $28,000 today.